exFAT, Extensible File Allocation Table, is a file system introduced by Microsoft in 2006 and optimized for flash memory such as USB flash drives and SD cards. exFAT was proprietary until August 28, 2019, when Microsoft published its specification. Microsoft owns patents on several elements of its design. exFAT can be used where NTFS is not a feasible solution, due to data structure overhead, but where a greater file size limit than that of the standard FAT32 file system, i.e. 4 GB, is required. exFAT has been adopted by the SD Association as the default file system for SDXC and SDUC cards larger than 32 GB. Windows 8 and later versions natively support exFAT boot, and support the installation of the system in a special way to run in the exFAT volume. exFAT was introduced in late 2006 as part of Windows CE 6.0, an embedded Windows operating system. Support was added to regular Windows with Windows Vista Service Pack 1 and Windows Server 2008, both released on February 4, 2008. An update for Windows XP and Windows Server 2003 was later released. Most of the vendors signing on for licenses are manufacturers of embedded systems or device manufacturers that produce media formatted with exFAT. The entire file allocation table, FAT, family, exFAT included, is used for embedded systems because it is lightweight and is better suited for solutions that have low memory and low power requirements, and can be easily implemented in firmware. Features: because file size references are stored in 8 instead of 4 bytes, the file size limit has increased to 16 exabytes, EB, 264 1 bytes, or about 1019 bytes, which is otherwise limited by a maximum volume size of 128 PB, or 257 1 bytes, raised from 4 GB, 232 1 bytes, in a standard FAT32 file system. Therefore, for the typical user, this enables seamless interoperability between Windows, Linux, and Mac OS platforms for files in excess of 4 GB. Windows XP requires update KB 955704 to be installed, and Windows Vista requires its SP1 installed. 14.15.16 Windows Vista is unable to use exFAT drives for Ready Boost. Windows 7 removes this limitation, enabling Ready Boost caches larger than 4 GB. Windows 10 only allows formatting exFAT and NTFS on non-removable volumes sized larger than 32 GB with the default user interface, and FAT32 format is suggested for smaller volumes. Command line utilities don't accept quick format using FAT32 if volume is larger than 32 GB. The standard exFAT implementation is not journaled and only uses a single file allocation table and free space map. FAT file systems instead used alternating tables, as this allowed recovery of the file system if the media was ejected during a write, which occurs frequently in practice with removable media. The optional texFAT component adds support for additional backup tables and maps, but may not be supported. The exFAT format allows individual files larger than 4 GB, facilitating long continuous recording of HD video, which can exceed the 4 GB limit in less than an hour. Current digital cameras using FAT32 will break the video files into multiple segments of approximately 2 or 4 GB. EFS supported in Windows 10 v16.07 and Windows Server 2016 or later. Efficiency: SDXC cards running at UHSI have a minimum guaranteed write speed of 10 MB/s, and exFAT plays a factor in achieving this throughput through the reduction of the file system overhead in cluster allocation. This is achieved through the introduction of a separate cluster bitmap where the reservation state of each cluster, reserved/free, is tracked by only one bit, reducing writes to the much larger FAT that originally served this purpose. Additionally, a single bit in the directory record indicates that the file is contiguous, unfragmented, telling the exFAT driver to ignore the FAT. This optimization is analogous to an extent in other file systems, except that it only applies to whole files, as opposed to contiguous parts of files. Adoption. exFAT is supported in Windows XP and Windows Server 2003 with update KB955704 Windows Vista Service Pack 1 and later, Windows Server 2008 and later, except Server Core, 20 Mac OS starting from 10.6.5, Linux via Fuse or natively starting from kernel 5.4, and iPad OS as well as iOS starting from 13.1. Companies can integrate exFAT into a specific group of consumer devices, including cameras, camcorders, and digital photo frames for a flat fee. Mobile phones, PCs, and networks have a different volume pricing model. exFAT is supported in a number of media devices such as modern flat-panel TVs, media centers, and portable media players. exFAT is the official file system of SDXC cards. Because of this, any device not supporting exFAT, such as the Nintendo 3DS, may not legally advertise itself as SDXC compatible, despite supporting SDXC cards as mass storage devices by formatting the card with FAT32 or a proprietary file system tied to the device in question. Some vendors of other flash media, including USB pen drives, compact flash, CF, and solid-state drives, SSD, ship some of their high-capacity media pre-formatted with the exFAT file system to ensure compatibility with any given device. For example, SanDisk ships their 256 GB CF cards as exFAT. Microsoft has entered into licensing agreements with BlackBerry, Panasonic, Sanyo, Sony, Canon, Aspen Avionics 28 AudioVox, Continental, Harman, LG Automotive and BMW. Mac OS X Snow Leopard 10.6.5 and later can create, read, write, verify, and repair exFAT file systems. Linux has support for exFAT via Fuse since 2009. In 2013, Samsung Electronics published a Linux driver for exFAT under GPL. On August 28, 2019, Microsoft published the exFAT specification and released the patent to the Open Invention Network members. The Linux kernel introduced native exFAT support with the 5.4 release in November 2019. Chrome OS can read and write to exFAT partitions. Technical specifications. Windows 8/10 defaults to exFAT on volume sized greater than or equal to 32 GB, and FAT32 on volumes 32 GB. File name lookup. exFAT employs a file name hash-based lookup phase to speed certain cases, which is described in U.S. Patent Quick File Name Lookup using name hash. Appendix A of the document contains details helpful in understanding the file system. File and cluster pre-allocation. Like NTFS, exFAT can pre-allocate disk space for a file by just marking arbitrary space on disk as allocated. For each file, exFAT uses two separate 64-bit fields in the directory, the valid data length, VDL, which indicates the real size of the file, and the physical data length. To provide improvement in the allocation of cluster storage for a new file, Microsoft incorporated a method to pre-allocate contiguous clusters and bypass the use of updating the FAT table, which was patented December 10, 2013. One feature of exFAT, used in the exFAT implementation within embedded systems, provides atomic transactions for the multiple steps of updating the file system metadata. The feature called Transaction Safe FAT, or TexFAT, was granted a patent on November 3, 2009. Directory file set. exFAT and the rest of the FAT family of file systems do not use indexes for file names, unlike NTFS, which uses B-trees for file searching. When a file is accessed, the directory must be sequentially searched until a match is found. For file names shorter than 16 characters in length, one file name record is required, but the entire file is represented by 332-byte directory records. This is called a directory file set, and a 256 megabyte subdirectory can hold up to 2,796,202 file sets. If files have longer names, this number will decrease, but this is the maximum based on the minimal 3-record file set. To help improve the sequential searching of the directories, including the root, a hash value of the file name is derived for each file and stored in the directory record. When searching for a file, the file name is first converted to uppercase using the upcase table. File names are case insensitive, and then hashed using a proprietary patented algorithm into a 16-bit, 2-byte, hash value. Each record in the directory is searched by comparing the hash value. When a match is found, the file names are compared to ensure that the proper file was located in case of hash collisions. This improves performance because only 2 bytes have to be compared for each file. This significantly reduces the CPU load because most file names are more than 2 characters, bytes, in size, and virtually every comparison is performed on only 2 bytes at a time until the intended file is located. Metadata and checksums. exFAT introduces metadata integrity through the use of checksums. There are 3 checksums currently in use. 1. The volume boot record, VBR, is a 12-sector region that contains the boot records, BIOS parameter block, BPB, OEM parameters, and the checksum sector. There are 2 VBR type regions, the main VBR and the backup VBR. The checksum sector is a checksum of the previous 11 sectors, with the exception of 3 bytes in the boot sector, flags and % used. This provides integrity of the VBR by determining whether the VBR was modified. The most common cause could be a boot sector virus, but this would also catch any other corruption to the VBR. 2. A second checksum is used for the upcase table. This is a static table and should never change. Any corruption in the table could prevent files from being located because this table is used to convert the file names to uppercase when searching to locate a file. 3. The third checksum is in the directory file sets. Multiple directory records are used to define a single file, and this is called a file set. This file set has metadata including the file name, timestamps, attributes, address of first cluster location of the data, file lengths, and the file name. A checksum is taken over the entire file set, and a mismatch would occur if the directory file set was accidentally or maliciously changed. When the file system is mounted, and the integrity check is conducted, these hashes are verified. Mounting also includes comparison of the version of the exFAT file system by the driver to make sure the driver is compatible with the file system it is trying to mount, and to make sure that none of the required directory records are missing. For example, the directory record for the upcase table and allocation bitmap are required, and the file system can't run if they are missing. If any of these checks fail, the file system should not be mounted, although in certain cases it may mount read-only. The file system provides extensibility through template-based metadata definitions using generic layouts and generic patterns. Flash optimizations. exFAT contains a few features that, according to Microsoft, makes it flash-friendly. Boundary alignment for file system structures. The offsets for the FAT and the cluster heap is adjustable at format time, so that writes to these areas will happen in as few flash blocks as possible. An OEM parameters field can be used to record features such as block size of the underlying storage. One single type for flash storage is predefined. The lack of a journal, so that less data is written. Although FAT32 also lacks a journal. The first feature requires support from the formatting software. Compliant implementations will follow existing offsets. The OEM parameter may be ignored. Implementations may also use trim to reduce wear. Other implementations. Legal status. exFAT was a proprietary file system until 2019, when Microsoft released the specification and allowed Open Invention Network, OIN, members to use their patents. This lack of documentation along with the threat of a patent infringement lawsuit, as happened previously when Microsoft sued various companies over the VFAT long file name patent, before it expired, hampered the development of free and open source drivers for exFAT, and led to a situation where Linux distributions could not even tell users how to get an exFAT driver. Accordingly, exFAT official support was effectively limited to Microsoft's own products and those of Microsoft's licensees. This, in turn, inhibited exFAT's adoption as a universal exchange format, as it was safer and easier for vendors to rely on FAT32 than it was to pay Microsoft or risk being sued. Interoperability requires that certain results be achieved in a particular, predefined way, an algorithm. For exFAT, this potentially requires every implementation to perform certain procedures in exactly the same way as Microsoft's implementation. Some of the procedures used by Microsoft's implementation are patented, and these patents are owned by Microsoft. A license to use these algorithms can be purchased from Microsoft, and some companies, including Apple, Google, and Samsung, have done so. However, in the open source ecosystem, users have typically responded to vendors being unwilling to pay for patent licenses by procuring an implementation for themselves from unofficial sources. For example, this is what happened with Lame when MP3 patents were still valid. Alternatively, the user may decide that the feature is unimportant to them. Regardless of whether open source or not, Microsoft stated that a license is required in order to implement exFAT and use it in a product or device. Unlicensed distribution of an exFAT driver would make the distributor liable for financial damages if the driver is found to have violated Microsoft's patents. While the patents may not be enforceable, this can only be determined through a legal process, which is expensive and time-consuming. It may also be possible to achieve the intended results without infringing Microsoft's patents. In October 2018, Microsoft released 60,000 patents to the OIN members for Linux systems, but exFAT patents were not initially included at the time. There was, however, discussion within Microsoft over whether Microsoft should allow exFAT in Linux devices, which eventually resulted in Microsoft publishing the official specification for open usage and releasing the exFAT patents to the OIN in August 2019. List of implementations. A Fuse-based implementation named Fuse exFAT, or exFAT Fuse, with read/write support is available for FreeBSD, multiple Linux distributions, and older versions of Mac OS X. It supports trim. An implementation called exFAT File System, based on Fuse exFAT, is available for Amiga OS 4.1. A Linux kernel implementation by Samsung Electronics is available. It was initially released on GitHub unintentionally and later released officially by Samsung in compliance with the GPL v2 in 2013. This release does not make exFAT royalty-free, as licensing from Samsung does not remove Microsoft's patent rights. A version of this driver was first incorporated into version 5.4 of the Linux kernel. A much newer version of the driver, with several bug fixes and improved reliability, was incorporated into kernel 5.7. Prior to its being merged into the Linux kernel, this newer version had already seen adoption on Android smartphones and continued to be used on both Linux and Android thereafter. Proprietary read/write solutions licensed and derived from the Microsoft exFAT implementation are available for Android, Linux, and other operating systems from Paragon Software Group and Tuxera. XCfiles, from Datalight, is a proprietary, full-featured implementation, intended to be portable to 32-bit systems. RTFS, from EBS Embedded Software, is a full-featured implementation for embedded devices. Two experimental, unofficial solutions are available for DOS. The loadable USB exFAT driver requires Panasonic's USB stack for DOS and only works with USB storage devices. The open-source exFAT executable is an exFAT file system reader and requires the HX-DOS extender to work. There are no native exFAT real-mode DOS drivers, which would allow usage of, or booting from, exFAT volumes. The renaming of exFAT file system labels is natively supported by Microsoft Windows Explorer, while Linux relies on the exFAT label and tune.exFAT tools, both part of exFAT progs. Thank you for watching this video.